Welcome back to Ox Tools. I'm Tom. So tonight we're fiddling around with, we got a whole bunch of these plastic blocks that we're poking holes in. And so there's a couple little techniques that I get asked about pretty regularly. And so we're going to talk about those kind of as mill production tricks. So we'll take a look at those and we can talk about that, and you can see some of those techniques. So let's take a look at it. Okay, so here's the setup here. I've already got the stop set. I've been working on these. So so there's a couple things going on here. We got a large array of holes to put in. This is the same pattern here. This next set is a slightly different size, and I have multiple sizes to do. So we got to go along and do all those holes. So this question comes up quite a bit: is what's fastest, right? Drill a hole, move over, drill another hole, move over, move over, drill a hole, blah blah blah, right? Well, there's several operations going on here, and we have a hole, then we have a countersink, and we have positioning. So there's kind of three pieces to the puzzle here. And so now the numbers in this particular case, I would call them slightly messy. It's an odd spacing between these. So the numbers are kind of so 2.389, 3.528, 4.667. So they're kind of what I would call messy numbers. It's not like 1 inch, 2 inch, 3 inch, 4 inch, etc. Right? So in this situation, the fastest with multiple pieces here is, in this case, it's a very easy part change as opposed to tool change or table movement. So we'll go ahead and do a couple, and you'll get the idea. And then we'll talk about the countersink here too, because that's done a little bit different way too, to make them all uniform and not have to drive to each location. Okay, so here's the other bit of the puzzle here too. This looks a little weird probably to you guys. Well, this thing wants a flat bottom hole, or a reasonably flat bottom hole. And it happens to be kind of an oddball size. So you can use a boring bar, okay, that fits in a boring head. But a lot of those might not go to the center line. So in this case, I'm using an end mill that the shank fits in the boring head. And I've just offset it, and you'll see there, so that it runs out the right amount, okay, to give me the right size hole. Okay, so let's grab the little victim here. All right, so this is the little vial that this is a 4 milliliter vial that goes in there, and then that just drops right in. Some crud in there. Anyway, so you can kind of get any size you want with a flat bottom hole. So if you have odd size counterbores, you can use this trick to do odd size counterbores. So you find the end mill that's closest to that size, and then you just offset a little bit, and then you can do a counterbore like that. Okay, so let's change the camera around, and then we'll do a couple of holes, and you guys can see that process. All right, so kind of ready to go here. One thing I forgot to mention is, you see there's a fair amount of space here, and there's a good reason for that. Since we're going to be swapping the parts out, okay, I don't want this too close here, because it's too easy to lift this and bang that. You know, we're going to slide it out like that, but you know, a little extra handle stroke doesn't hurt us in this case here. All right, so what we're going to do is we're going to move to our next location. All right, I'm going to very conscientiously set this. I'm going to read the number 2.389, 2.389, look at my drawing, check my other axis, I'm good. Okay, so now I don't have to think about the DRO or where I am anymore. Now I've got a depth stop. Let's see, can you see that? Let's look at the camera there. Well, you can't quite see it, but I've set the hard stop here on the quill. That way I don't have to look at the depth. Now these holes are about 13 millimeters deep, 750 right there, bink. Okay, so now I just take that part out, slide the next one in, boom, go. Now that was quicker than positioning the table, okay? And that's the whole idea. What's quicker? All right. And I'm pecking just to break the chip, so I don't get a long, you know, stringies going whipping around on me there. You know, I could plunge and just go the whole way, right? But short chips are better. Okay, so now I move to the next hole and very carefully read the number again. 528. Okay, so rinse and repeat. Okay, I'm not going to bore you with the rest of this. All right, something else I guess I wanted to show. Let's see if you can see all that in there. Yeah, you can see that. I'm using some thick parallels here, and I also have a separator spring and a little block here to keep the parallels in place. So when you're doing something like this, where you're swapping the parts out, you really don't want to be messing around with parallels. So you want to be able to just put these in there and slide it in and not have the parallels go with the part, so that they stay fixed and they don't move around and chips can't get in behind them and stuff like that. So it's worth a little extra setup if you're doing multiple parts to, you know, get your setup. You know, we're just squeezing the vise a little bit here so we can set up I don't know, just a little bit better setup to keep the parallels in position. I wanted to point that out. Okay, so here's the next part of this deal here. These I already did here. It's probably hard to see, but they have a little countersink on, just to break that edge to make it so it's easier to put the vial in. So, you know, you could do these up on the mill and countersink them. But to move quickly between the holes, we'd really want this free on the table. So, you know, instead of depth stop, dot, 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 dot. Well, you can do that. Now, this is soft plastic, okay? So one of the dangers there is, with a countersink, is that it bites and actually gives you the suck fest and sucks the part up and overcuts the countersink, okay? Ask me how I know that, because I've done it, okay? So what we're using here instead is I have this is a little aircraft countersink here with these threaded countersinks, and this limits the depth of the countersink. And guess what? When you're countersinking in the side of an airplane, you really don't want to over countersink, so they provide a pretty good tool for that. Now this one, what I've done, and we're going to make a new little bushing here that fits the pilot of this countersink. This one is for this guy here, and it fits my bore and then limits my countersink depth. Okay, so I'm gonna pop this one off. It's just pressed on there, just a light press, and we'll make a new one that fits this size here, and then we'll go ahead and countersink those to a specific depth, and then I can just move real quickly without fear of suck fest. So let's go ahead and make that little bushing. All right, so the first step is what we want to what we want to do is, wrong way. We want to figure out, you know, how we want our little bushing to fit. All right. That one's a little tighter there. All right, so that's probably a little. What is it? 584. Those are 3, I don't know, 582, somewhere in there. Okay. All right, so 582, 581, somewhere in there. That's the OD of the bushing. And there's the other one. I pulled it off of that. And then the ID is just a little light press on the on that little pilot there. Okay, let's go over to the lathe. Okay, so I got a little chunk of Delrin here. We're going to make a bushing for that that countersink. So let's go ahead and do that. That's the stub of our old one, so we're just going to take that off. Do a little face. All right. All right, we'll take a little cut. This is just to get our tool calibrated, because I was using it for something else, or using a different tool. 9758. Okay, so we're set the DRO. Jesus Christ. Brains fried. Okay, so we're on a 579 target. Let's take a big chunk off. Alright, let's poke in there with this. I drilled it deep because I know I got to make another one, so and it's going to be the same size. It. So double check. Yep, okay. So I don't want a real tight fit because it's going to be rubbing on that, right? So, but I do want it. It might be a little bit loose. Let's see. It's going to be fine. Okay, so let's, we're going to knock a piece off. Chamfer action first. No particular length that we need, just enough to kind of pile it in there. Actually. So sometimes you can just you can just squeeze them and pull them loose, yeah. Okay, so let's press that on our little pilot and let's try it out. Okay, so I got a little test piece that's got some holes in it, so I don't have to work out the diameter on my good parts. Let's try that to start with. A little more than that. So it's not any particular countersink diameter, it's just to break the edge for a little lead in, you know. That's pretty good. Can always go a little more. Pretty good. Let's grab the little vial. What's this one? Yeah. And you can see I can just move from hole to hole pretty quickly. Okay. There's some little fuzz on there. Anyway, that's the deal. I got some more to do. You know what? I'm gonna go a little deeper. I think that's part of the problem, getting a little fuzz on the edge. I think I'm gonna go just a whisker deeper. Anyway, you guys get the idea. You can see you can move pretty quickly when you got a handheld tool like that. So.